So today, we're going to dive into a blueprint for what might just be the single most ambitious engineering project of the next 100 years. It's a deep space infrastructure project called HELIOS-MESH, and it's a plan that reveals a whole lot more than just the future of space exploration. It really gets at the future of power itself.
Let's just start with this idea for a second. You know, the most critical systems in our lives, the power grid, the internet, you name it, they work so well that we just forget they're even there. They become completely invisible to us. And this isn't just some metaphor anymore. Right now, as we speak, we have built an entirely new, invisible layer of civilization in orbit around our planet. It's this vast network of satellites that's so deeply woven into our daily lives that if it were to fail, the modern world would, quite literally, fracture.
So that's exactly what we're going to look at first, this invisible infrastructure above us. Because really, before we can wrap our heads around what's coming next, we have to appreciate what we've already built and just how much we depend on it.
I mean, just think about it for a second. Global communications, the atomic clocks that synchronize the entire world's financial markets, the GPS that runs all of our logistics, even our ability to track weather and respond to disasters. Every single one of those things now runs through this orbital layer. This isn't just for science anymore. It's essential, critical infrastructure.
Okay, so that's the world we live in right now. But what's next? Well, that brings us to our second section, HELIOS-MESH, a solar network. This is where we make the jump from that sort of passive orbital layer we just talked about to an active, self-sustaining network that's designed to cover the entire solar system. This is the big vision. Now, the two words you really need to latch onto here are self-sustaining and distributed. This isn't just about launching a few more satellites into orbit. Nope. This is about creating a fundamentally new kind of architecture, one that can operate for decades without constantly needing help from Earth. And the scale they're talking about here is just, well, it's mind-boggling. The plan lays out a 4-layered mesh. It starts with what they call a LEO ring, that's low Earth orbit, with over 1,000 nodes just to blanket the Earth. From there, it expands out to connect the Moon, then adds another dozen or so nodes to cover Mars and the asteroid belts, and finally, a deep space relay to reach the outer planets. We're talking about a solar system-wide web.
So you're probably thinking this all sounds a little like science fiction, right? Well, it's actually grounded in a handful of very specific technologies that are either ready to go or are on a very clear path to being ready. So let's look at the core breakthroughs that are going to make HELIOS-MESH possible. First thing you need is a new kind of engine. So imagine a rocket engine with 0 moving parts. That's pretty much what MHD propulsion is. Instead of pumps and turbines, it uses these incredibly powerful electromagnetic fields to shoot out propellant. And what that gets you is the kind of insane reliability you absolutely have to have for missions that need to last 20 years or more.
Next up, power. You know, solar panels are great around Earth, but they become pretty useless once you get out past Mars. The solution? These compact nuclear reactors. They use a substance called thorium, and they can provide a steady stream of power for decades, which means these spacecraft can operate literally anywhere in the solar system, totally independent of the sun.
And finally, how in the world do you navigate when there's no GPS? Well, the answer is quantum navigation. It's a system that uses the weird quantum behavior of supercooled atoms to measure movement with incredible accuracy. The key thing to understand is that it's basically an unhackable deep space compass that lets these nodes fly completely on their own.
Now, what I love about this slide is that it brings all this futuristic tech crashing back down to reality. You can see right here that some parts, like the computing, are basically ready to go right now. Quantum navigation is already in the demo phase, but the really wild stuff, the propulsion and the power, and you can see the thorium reactor is marked as high risk, well, those are on a clear 10-year path from the laboratory to being ready for space. So yeah, it's ambitious, but it is not a fantasy. But all of this incredible tech is really just setting the stage for what is, without a doubt, the most revolutionary part of this whole plan. And that's what we're going to cover next, refueling in deep space. This is where things get really interesting.
See, every single space mission ever launched has been a slave to the amount of fuel it can carry from Earth. It's this fundamental limit that engineers call the tyranny of the rocket equation. HELIOS-MESH aims to completely shatter that limit by using what's called In-Situ Resource Utilization, or ISRU, which is just a fancy way of saying it's going to harvest its own fuel directly from space. This isn't just some small improvement. It's a total game changer for how we operate beyond our own planet. So, where's this fuel going to come from? Well, the plan actually has two sources. The near-term goal, the one that's almost ready to go, is to literally mine helium from the dust on the moon. But the long-term vision, the really audacious one, that's to harvest helium directly from the atmospheres of gas giants like Uranus. It's basically a two-step plan. Start in our backyard, then move out to the rest of the solar system.
But let's be really clear about the engineering challenge we're talking about here. Just look at this number. To get 1 single gram of a special kind of helium from the moon, you'd have to process over 150 tons of lunar soil. That one number tells you everything you need to know about the incredible scale of this thing. We are talking about heavy industry on the moon.
So here it is, the whole vision in 3 simple steps. This is the cycle that makes everything work. You harvest helium from the moon or a planet, you process it into a usable fuel, and you use that fuel to power the network. It creates this perfect, self-sustaining loop, an infrastructure that can operate and even expand for decades, all by itself, finally and completely untethered from Earth.
So, what does this all add up to? Let's zoom back out for our final section and connect all this incredible technology back to where we started, that idea of invisible infrastructure and the true nature of power.
This quote, it comes directly from the project's own technical documents, and it could not be more blunt. The nation, or the company, that builds this network, they won't just be exploring space. They'll be building the foundational infrastructure for an entire solar system economy. And in doing so, they will effectively own it. And please, don't make the mistake of thinking this is some distant sci-fi dream. The roadmap here is aggressive, and it's already happening. The foundational tech is being tested right now. The lunar demos in the first part of the network are planned for before 2032. And the first operational Mars missions are slated to launch before 2036. This future is being built in the next 10 years.
Which leaves us with one final and maybe the most important question of all. The next great human infrastructure, it won't be built on land or under the sea. It's going to be built in the silent vacuum of space. And as that network becomes as vital and as invisible as the power grid beneath our feet, who do you trust to build it?